hope that you have the same reaction by the end of my talk. So I'm going to try and keep you entertained, and I appreciate it's the last talk of the day, and you'll all be itching to do whatever you're doing this evening. Just before we start, just out of curiosity, has anybody done any Clojure or Clojurescript before? Oh, a few people. Anybody consider them an expert? Oh, okay, right, okay. Oh, no. You shouldn't have told me that. Are you doing anything in December? Because we've got a conference, if you want to come and talk. But there we go. So this is, it did say beginners on the door, so just a bit of a cut. I'm the beginner. I've learned, I tend to learn a lot by conference talks, so feel free to ask me any questions. I'll try not to Google everything. But I'll try and tell you if I know something. If I don't know something, I'll try and find out and let you know. So let's get started. Are we good? Yes, the man at the back says we can start. So thank you very much for coming along. And it's a lovely sunny day in Amsterdam. So I'm going to talk about making the front-end development fun. So who's a front-end developer already? And who's just like does it a little bit every now and when they have to? Okay, so most people are kind of front-endy, and who loves JavaScript? Who loves everything about JavaScript? Okay, so most people love JavaScript, but not necessarily everything. Well, that's good. That's kind of my talk. So JavaScript is everywhere. It's a very pervasive platform. It's everywhere. You can deploy. You can write something and deploy it on the browser, but you can also do it on Node. You can also do it on mobile devices now as well, with things like React Native as well. So it's pretty easy to write something just in JavaScript and get it deployed pretty much everywhere you want to do. But there are a few quirks with the language. I think we may agree that it's not the perfectly designed language, but it's really good and it's evolving and some really interesting technology in there. I do struggle a little bit with some of the syntax. I think if you know what you're doing, you can do some really, really nice JavaScript, but it's quite easy to fall down some strange little nuances of the language. And the problem for me is it's a very loosely kind of designed language as well. So it's a little bit crazy to actually understand for me what the actual code is doing. So it takes a lot of work to read through JavaScript. And there are quite a few other languages as well. There's a lot of things there that you have to kind of navigate just to figure out what's actually going on. So computers are really great at figuring out what to do with the code. It's the humans that kind of find it hard to actually understand it. Not just other people's code, but your own code that you wrote a few months ago, thinking, what did I do there? What does it mean? I can't remember. So hopefully I'm going to show you that Clojure gives you a little bit more of a structure and a potentially simpler way to do things as you get used to it. So let's talk about Clojure. So to convert from Clojure to JavaScript, you can kind of take your function name and just stick it within the bracket. And then if you're defining vars, then you can use def to define names for binding of values. The fun thing is that a value can actually be a function call. So function calls always return a value as well. So you can define names for values. There'll be simple values, where there'll be numbers like 1, 2, 3, or strings. And values can be another function call, because you're always going to get that there as well. And the things that these names point to with def are immutable, or typically immutable as well. So there's a lot of things that are fixed. Once you create a string in most languages, then it stays a string. You apply a function to it and you get a copy. That's not universal for all the types. A lot of programming languages will mutate something, will change the state of something, which is fine when you've just got one piece of code, but when you've got a large piece of code, then it makes it harder to follow what's going on. So the actual syntax of Clojure, they're the same language essentially, but it's very simple. It's a very small language, so you've got a namespace that you can define just to organize the structure of your code. You've got define, where you're defining a function, and it's got arguments and some kind of behavior inside there as well. So it's packaging up different kind of functions within a namespace typically. And those functions act on data, and you usually give a name to your data as well. So you can basically, if you've got a big collection, you give the collection a name, so you don't have to type all that collection in all the way through your code. And you've got things like keywords as well, which are really cool for looking up information in maps. And you can also chain functions together. So we'll talk a little bit about chaining functions and one function calling another function, calling another function. In this example, we've got function A with an argument of some data. The result of that goes into function B as a result, as its argument, and then the result of that goes into function C, and so on. So you can kind of very easily chain functions together. And it's kind of like building up the Millennium Falcon with Lego bricks. You kind of just glue these things together and they work nicely. And all of this is kind of driven by immutable data structures. So you've got list, vector, a map, hash map, and a set. And again, once you create these things, then they can't change them. So what you do is you run functions over these things, and you get a result. You get a new result, a new collection in return. So you're not actually changing the underlying thing. And we'll talk about why that's important in a moment. And then you can do, there's over 650 core functions there that you can learn, but you don't need to learn all of them. This is kind of like the basic API of Clojure. So you get things like map and reduce. And all these things are kind of very data-centric, so a lot of it is about converting one piece of data into another piece of data, and that data is immutable as well, so you can actually do this in parallel very easily as well. And so all of this is kind of to do with dealing with complexity. Because as I was mentioned before, if you've got a very complex system, it's very hard for you to keep all that in your head. And even if you can, if you've got mutable states or things changing other parts of your program, then what is it actually doing? How can you be sure what your code is actually doing? If you're calling something, but it's using an external piece of data, or it's affecting another object somewhere else, then you can never be quite sure what it's doing. So you have kind of like a surface API of your code, but underneath it could be doing all sorts of weird and wonderful things. So there's this idea of side effects and side causes. So if you've got a function, and all it does is take an argument and give you a result, then it's very deterministic. You understand exactly what it's doing. It's not affected by any other part of the system. Whereas if you're pulling in information from outside of that function, or you're affecting other objects or other parts of your system by what your function does, it becomes harder and harder to actually reason about what your program actually does. So therefore, you get all these interesting side effects of your application, and it becomes much harder to debug them and find out where the problems are. So an example of how we deal with this in Clojure is this idea of pure functions. So we have here a function that I'm defining called increment numbers, and we pass it an argument of number collection, and that's simply going to take that number collection, and here we're using this example of chaining functions together. We're going to map one function over this collection. So we're going to take the inc function, which all it does is just add one to just increment an integer value, and so we're going to map that over each value of the number collection. And so if we give it 1, 2, 3, 4, 5, then we get 2, 3, 4, 5, 6 back in return. And whatever number we give it, we know exactly what it's going to do under all situations. It's not going to be affected by something else. Whereas if we have an impure function, we're pulling a value in from outside, like this global value. We got the same kind of function again, but this time when we give it 1, 2, 3, 4, 5, it's actually giving us 6, 5, 4, 3, 2, 1. So what's going wrong? Well, we're actually, instead of using the argument, we're actually using this global value. So we're actually pulling an external thing in. So this is just a very simple example, but you can already see that we can't always tell, because if something else is changing this global value while we're working and before we're working or after we're working, then we've got already some inconsistency in what our application actually does. And so one of the aims of functional programming is to try and eliminate this consistency, really. And also composing these functions so you can build things up in blocks as well. So there's this really cool map-reduce sandwich example. Has anybody seen map-reduce sandwich before? 1 to 2 people. So we've got our ingredients for our sandwich. We're going to map this function called slice over it, which slices all the ingredients. So this is it's a function that's acting in parallel on all those ingredients. So if these ingredients are all immutable, you're going to change them into like slice versions of themselves, and then you're going to reduce them into a single sandwich. So we can do that in code. So we've got a slice function. Oops, wrong one, wrong button. We've got a slice function here, and all it does is just add the word slice to it. It's kind of a pseudo slicing. So we've got our ingredients: bread, cucumber, pepper, tomato, lettuce, etc. And we're going to map slice over each of those. So we'll get sliced bread, sliced cucumber, etc., etc. And we can make the sandwich by kind of interposing a little comma in between all of the ingredients, and then string them all together so they make one big sandwich. And then this is our awesome UI, which is just a print statement out to say we've made a sandwich. So we're actually mapping slice over it. That's the map part. And then we're reducing it into a single sandwich, and then having that for dinner. Does that make sense? Yeah, cool. Everybody's awake still. Yay. Cool. And then there's the other way. This is kind of like the alternative syntax, because you can get, you could have that all in one big expression as well. This is sometimes people prefer writing this as just a potentially simpler way to actually understand what's actually going on. And the main reason this is then you can do massive parallelism. You can run things on multiple cores, multiple servers, multiple containers, multiple microservices, because the underlying data structures are all immutable, so that you can build up very highly scalable systems because you've got pure functions and you've got immutable data. So you can actually change the world, potentially, if you get a good idea. And there's also this idea of managing state as well. So if you do actually want to change something, if you want to mutate something, then we can do that safely. There's something called software transactional memory. It's like having a transactional database inside your computer. If you've ever done languages like Java or C#, then that's managing all the memory management for you. So it manages like opening and closing kind of memory references. This is like doing the same thing for when you want to actually change state. So here we're actually doing we've got a simple online gambling system where Harriet is going to create an account, and we do so in this doSync thing where we're actually using this ref, this mutable box. So inside this mutable box, we've got just an empty array, an empty vector. So that's immutable, but we put it in this mutable box so we can actually change that value that we want to keep track of. So we want to keep track of how much money we've got as a gambling company, so we can keep enticing people in and giving them their free 100 credits. But we want to add users, but we want to do that safely. So we call join safely with Harriet. We give it Harriet's account and the game account, and then it's going to update the player collection. So she's going to add Harriet as a player. It's going to give her 100 credits, and it's going to take away 100 credits from the game account, so we know how much we've actually got as a company. And that way we can manage changes safely, and anything else that's trying to change the game account has to wait until this completes. And also, if one of these things didn't complete, then it would all roll back for us as well. And that's all managed internally inside Clojure as well. So that's kind of some of the basic fundamentals of Clojure and Clojure and so let's move on to actual making the web hopefully a bit more fun with that language as well. So where does this fit into the web? Who's doing jQuery stuff? A few people, okay. And anybody doing single-page apps? More people, yes. Oh, that's a nice breezer. Oh, that's lovely. So this is where Clojure really shines, building single-page apps. And so we've got some really nice tooling around it to create very optimized Clojure as well. So we use the Google Clojures with an S rather than the J to compile Clojure into JavaScript. So this is what it makes it actually Clojure because it's the same language as Clojure, but it's just generating JavaScript instead of JVM bytecode. And there's also, you can also do this on the .NET platform, and somebody's also doing it for Go as well, so you could actually write in Clojure and deploy to a Go platform, and an NPM and quite a few other different platforms as well. And there's lots of examples of use of Clojure. There's Circle CI, which is an online CI tool, which is really nice. That's all using Clojure and they publish a lot of their code on GitHub as well, so you can see examples of what they've done. And so how do we get started? Same way as you do with Clojure, there's a build tool called Leiningen, so we don't have a range of build tools. There's Leiningen. There's also Boots as well, which is a fairly new one. But most people use Leiningen, so it's a simple tool with a plugin called Figwheel, so it's very easy to get going. And Figwheel, and there's like templates as well to help you start, so it actually builds a full stack project, and that's the one we're going to go through in a moment. We'll walk through some code of this template and how I built it into a fairly simple React-like application. And all these slides are going to be on the internet very soon. So let's come to React very briefly. Who's been using React before? Oh, most people. Who understands how React works? Oh, a few people admit that as well. Excellent. If I get anything wrong, please let me know. But essentially, if you boil it down to the really basics, your application is generating some new data. From that, you build a new virtual DOM. You give that to React, and it compares it with the existing document object model, and then it decides how to update the browser. So this is kind of like where React works, and you just have to make your application do the right thing. So it takes care of updating the UI and making sure that it's a very fast update. It's only updating what needs to be done. So if there's some state changes in the UI, either from external systems or from user action, then React is going to decide which bits of your web page are actually going to get updated. And it encourages, obviously, a component-based approach as well. So you have one or more components that make up your single-page app. Sometimes you have like a component that's made up of a number of components. And so the idea is that these components are also reusable as well. So you're not continually rewriting the same kind of code as well. So let's code. Ooh, that's a good idea. So the rest of the talk is really about coding. So I've got an application. I've just created this just with command line. I just used this command line tool called Line, which is the Leiningen build tool. So this allows us to create projects, but also build things. I'm using here just line, new, Chestnut is the template, and Clojure X is the project I've created. And this has created me this kind of full stack project with a project file, project configuration file, and then I've got resources for my CSS, for my HTML, and also then a source tree. And so if you're doing Clojure, typically when you're doing Clojure you might do Clojure on the server side, so you'll have like a server-side component, and you'll have Clojure JavaScript, which is your client-side component, and then there's also Clojure Common, which is kind of libraries that will work on both the front end and the back end as well. So it's not tied to a particular host language, whereas Clojure might have some Java code in it, or some Java interrupt code in, and JavaScript could have some JavaScript code in it as well. But Clojure Common would actually work on both platforms. So let's go. Is there any questions so far? No? All simple? Maybe? Cool. So let's see. So there's my... So I'm actually running... I'm using Emacs, but you don't have to. There's quite a few different editors you can use for Clojure. And I'm actually running a REPL, a runtime environment, inside my editor. So my code is connected to the REPL, this runtime environment for Clojure And that REPL actually is running in my browser. So when I go to it's the JavaScript engine inside the browser. So here I've got a program that just does something very simple. I think you can work out what it's actually doing on the page. And it's basically got an app state, this state of my application called hello chestnuts. So it's just a string that's referred to by this key in a map. And I'm just going to put that in. And then all I'm doing is going to have this render component. So they've got this root component, and it's going to render. It's got this render function, and it's going to render me a div. A lot of React stuff likes divs everywhere. If you're going to create something, you usually have to wrap it in a div. And inside that div, there's this h1, this header element, and the value of that is going to be what we pull from the application state. So whatever value we put into hello chestnut, that's going to be, whatever value we put into this text key, that is going to be displayed on the page. And, last bit. And then we've got this root function, which actually displays this component or the components it's referring to onto the actual page. So there's a div on my index.html, which is called app, which I get by doing a bit of JavaScript. So this is the JavaScript interop. So we're going in and pulling off this, we're calling this JavaScript function, get element by ID. You may have used that yourself before in JavaScript. And all we're doing is defining that as the target. So that's where we're going to draw our component, render our component. And we're going to call the root component, and we're going to pass it the current app state. And so this is making it draw our string on the page. So, oops, that's the wrong key. So rather than type it all in, I've put some of these into branches, so you don't have to, well, actually tags, because from the last talk, we're not allowed to use branches anymore. It's very naughty. So I've got a number of tags I've got in my Git. So I'm going to just change branch, branch checkout. Number 2. So now we're going to show you some REPL-driven development. Oh, there we go. And so my file's just updated to add some extra code in here down the bottom. Yes. Oops. And so I can work with my code in the REPL. I can open up a REPL window. Let's see. Which opens up this REPL window down the bottom here, and I can go into the namespace. Oops, if I can type. What was it called? Clojure core. Come on. Oh, there we go. And I can go and ask it what my app state is, and it will just return the text. I'm going to switch these around, actually, because it's a bit easier to see. Boom, 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 boom. But there we go. Oops. Oh yeah, is that better? There we go. So my head's not in the way now. But I can also go in and change the REPL from the text as well. Boop. Oops. So now I'm interacting with my browser, and it's changing the input there. So you get a really fast turnaround. Obviously, I'm still a bit slower because I'm presenting, but it's fast as well. And I can also do that from my editor as well. Editor. Boom, boom. So even though this code is commented out, I can still kind of interact with it as well and evaluate it and send it to. So you can get a real kind of feeling about what you're actually developing as you're developing it. And so REPL-driven development, I think, just makes it a really fun experience when you're actually coming around to building things. So let's look at the next step. Oops. Come on, what's it going? It's going up, it's playing around. Let's try that again. Nope. There we go. does it do? No. There we go. So we go to 3. So I'm going to make a little simple change to my code. So now we're going to we change the atom to have a conference rep and a conference name, and it should have. There we go. So now we've changed the code to a conference name thing there, just by changing our app state and the code that we use to display the app state as well. So we can interact. We can define lots of aspects to our root component. There we go. And then where did 3 go? Oh, there it is. Oh, I'm already on there. Sorry. 04. And so now we've got. There we go. I've defined some more components. Some more data for us to play around with. So I've changed the. I'm going to change the state. So the app state at the moment, I can I can quiz that from inside my editor, and it's just Clojurex. It's just a conference name, and I can also reset that as I wish. But I also go and add session data, so I can just go and add data to that as well. I can experiment with that. So I can experiment what kind of data structures I actually want. And I've defined just a name for my data structure here. So it's a map, and it's got basically key value pairs just to define what my talk is for a conference. And so the idea is keep on building this conference talk. And so I can just refer to this whole map as John. So here we're just basically going to swap the app state by associating at the key where the session is, the value of this John name that we've created here. So do that, then that's my session. We can see that in a bit more detail. So this is this is now part of our app state. So we've got our conference name and a session, but obviously we have more than one session in a conference, hopefully. Otherwise it'd be either a very long session or a very short conference. So let's close it. But we're still not displaying anything because we're just playing around with the actual model of it. We're trying to define what would actually look good, how we would actually manage it, how we would work with our the right data structure for our functions. So let's go to the next level. 5. So let's have some multiple sessions. So now we're going to change the app state. And we're using this def once, which is a little bit different to a normal def. So this means that once we've defined what an app state is, then we don't want to overwrite it. So what we're doing every time I make a change, then I'm actually, those changes are getting sent automatically to the browser. And so to stop certain parts of it being updated every time there was a change, then if I didn't use def once, then it would just reset the state every time I did a change, which is a bit, it slows down the process because then I have to reload all the sessions and so on. And I've updated the reset function here. So this is just a little helper function I'm using to reset the date, reset the application state. And I can swap in sessions in there into that and control it. And so now we can add more and more sessions to the application state. So if we're going to look at my state now, so now I've added myself twice because we don't have any more, but we can keep on adding in more and more sessions because all we've done is just put them into this vector, this array, and we can just keep on adding more and more sessions. We don't really care, because we don't know which order the sessions are going in yet, so we might do it in the order we add them. We might want to add something to the model to kind of control how we order the state, or how do we define the order of the state. Boom. So let's go to the next branch. Branch. No. 3, 6. Oh. Oh, what's it done? What have I done? Oh. Sorry. There we go. I updated something I didn't want to. Oh, there we go. There we go. Oh. Oh. Oh, wrong one. There we go. Let's try it again. There we go. Yeah, that's better. Move that down a little bit. So now we've added an extra talk, and we can. Did I add that there? And I've also added to the root component these kind of details, so we can actually see the talks now. Actually see the talk live on the web page, and if they weren't quite right, we did something wrong, we could actually go in and reset these, reset the applications. So yeah, there we go again, and then okay, we can add them one by one just to make sure. If one of them was causing a bug, we could add them individually and see what was actually going on. So we can add the states over and over again. So you see, there's like the interactive nature of Clojure is really good. Does for me help make it a fun environment to work in. And so yeah. So the main thing we've done here is, I'm going to make this bigger again, is actually just update the root component. And so as well as having this H1 element, that's just a conference app, we're basically going to loop through the collection. We're going to iterate over the collection, or it's like a Lisp comprehension in Clojure. So we're basically creating this for each of the elements inside our session, which the moment that we have two at the bottom, we have my talk and we have Phil's talk. Then we're going to pull the first element out, so we'll pull my talk out, and that'll be referred to as a local name called session. And then we can then go in and say, well, we want the title as a H1, and we pull out the session string that's referred to by title, and display that as the H1 contents. And then we are adding a string for the speaker name, so we're just putting this by speaker name on, so we're just creating a little function here to tag on the word by to the speaker name, and then we're pulling out the other information from session app as well. Because if we go right back to when we're actually calling, when we're calling root component from root, we're passing the app state. So this app state is given this local name called app, as it's the argument name for root component. So when we see app, this is our app state. So our conference name can pull the string that it points to from that app state. And the same thing with sessions and title and so on and so on. And so these are just basically HTML elements, but using a library called DOM, which actually generates the HTML for us. So rather than having to write all the angle brackets and closing them, you're writing Clojure, which then generates the HTML for you. Is there any questions? Is that all fairly simple? Yeah, cool. Let's hope I didn't change anything. There we go. So we go to the next one. Bootstrap. And so at the moment, it wasn't looking very pretty. So we're going to add and change it to use Bootstrap. Now, here I'm adding a new library, so I've just done a reload of the browser just to get it to pick up, but you can notice that the font has slightly changed. So it's now using the Bootstrap font. All I did to add that was to add Bootstrap to the index.html file. So we're going to have a look at the web page, which is in resources, public index.html. then this is just pulled, this is just the links that just pull Bootstrap from the CDN. So who's used Bootstrap before? A few people? Not most people. So yeah, so we're just using the links for Bootstrap just to add the theme. It saves me downloading it and installing it locally. Obviously, if you're going to do offline development, you might want to put it locally or put it as part of your pipeline. And it's just including the CSS and the theme and the JavaScript to make it all work. And it's, as we reloaded the page, then we need to go back and add the state back in again. So let's close that. Did I add them here? No, I didn't. And if to do that, I'm going to go 8. Is that it? Oops. Didn't want to do that. There we go. So I've got some helper functions that will help me do that. So again, I'm just writing these little functions in here so I can, again, use the REPL to, I can reset the app state. App state, obviously it's reset already, but I can also load the sessions as well. So I'm just loading the sessions back in, and then it puts our content back in there as well. So it's not quite perfect. It's it's using Bootstrap, but none of the styles are there. And so far, what we've got is just code that displays it. So we're looking here. We've just got DOMs. We've just got HTML elements. We haven't got any styling attached, but you see all these nils. These are the options that we can. These are the properties we can apply to these elements as well. See if I go and add the next branch, which is 9. I can add a container so that now we're kind of like got a margin around our application. And if we go into branch number 10, we can add a Jumbotron. We all love the Jumbotron. Does it show up on there? Oh, it doesn't. If you come and look at my computer, you can just see a faint gray. I'll have to change the color of that because it never shows up. But now we're adding like a big box for the heading there, and it's subtly changed the text of that as well. And we can go in and change the rest of the code as well. To 11. We can add, so it's looking a little bit better there. Let's put some panels around there so you can actually distinguish between the different talks and make it a lot easier to understand what's going on. And all this is doing is just adding, let's make this a bit bigger, we're adding these class names. So if you've used JavaScript, you'll be familiar with the idea of class name. The difference here is we're defining this using Clojure. So we're defining the styles in a map. So we've got a name, class name is the key, and then the name of the style that we're applying. So we've applied a container, a Jumbotron, we've applied a panel to make it look blue, and we made it a primary panel. And because these are Clojure script ones, we just need to run a little function in front of them called hash.js. It's just a little macro that will convert our Clojure script structure into JavaScript, because the DOM element is going to need the JavaScript equivalent of this, so it's going to create like the property that's the equivalent of this style that we're adding. Does that make sense? Yep. Ooh, we're about out of time, I think. But see what else we can add. Let's see. Boom, boom, boom. Nope. Oh, wrong button. So we've done container. We can refactor into components, and I'm going to add an input form with a click handler, and then so now we've got this new form that's added. If I click on it, it adds more things. It's just using placeholders by default, so it's nothing. But you can go and add their own content as well by typing in the form, obviously. So we're just adding another component here. So we've got a sessions detail, which I've separated out from the root components. I've added a session add, which is drives our form. So it's like a normal form with inputs, text areas, et cetera, and a button. And this is where we get the kind of the JavaScript stuff. So we're preventing React from triggering an event every time we type. We're just waiting for the submit button to be pressed, and then it'll update our app state. And it's just putting placeholders in. So if you don't put a value in, it's just going to put placeholders in return. And yeah, but apart from that, that's kind of the same. So, and then we've got two separate components, so we then need to add them. We need to build them. So we have the root component building our two other components. We only have one component that's our overarching application, but it builds two other components to make itself up, to add the session details and add the form as well. And then I think, what else? One last thing, and then we're wrapped up, I think. Yeah. So I've jumped over a few of these, but I have detailed this online as well, all these individual steps. And I'm going to just go and jump to the last one, I think. There we go. And so now we've connected up the code we've defined this local state. So we've got this placeholders of local state. So our component's going to manage the state of the form is going to generate, and also help use that state to update the form as needed. And we're just using this set state to be able to link what's actually going on in the form itself back into our application state. And then hopefully it all still works. There we go. Oops, that's the wrong button. Where is it? There is good documentation online. There we go. And then hopefully I'll be able to add if I didn't, I messed up something. There we go. There we go. Boom. Yeah, so we can add the form in, and we can add things, but every time we, oh, that's interesting. I've got a bug there. But we can add the form, so we can actually keep on adding more and more things. It's just all it's doing is just updating the state over and over again. And we can also go back and check what our state is, what's actually going on inside our live running environment anytime we want by going in and doing app state, up state, there we go. And there we can see all our information, what's happening as well. So again, because Clojure is a very data-centric stuff, being able to see what the data is and be able to understand what all the functions are doing at any particular time is very, very powerful and really helps you kind of drive your understanding of what your application is doing. So I went through that quite quickly. I appreciate you won't be able to necessarily follow everything that we've done, especially when you get down to setting connecting the forms up with the local state. But this is online. I put this on a GitHub repository so you can kind of see how the whole thing has evolved. And I think I've just got a couple of slides there. Oh, I just got a final slide. So that was really just a quick introduction into getting going with Clojure And so I hope you found that really useful, or at least kind of interesting, and hopefully it'll inspire you to go and try Clojure and Clojure out yourselves as well. If you've got any questions, I'll be around for a few hours as well. So thank you very much. Does anybody have any questions? Yes, you were slightly first.
I was wondering how long did it take you to learn? Sorry,
so how long did it take me to learn Clojure? Well, I've been learning Clojure off and on for, well, about 4 years. And I think Clojuscript, like 4 years ago, was very difficult. Now it's a lot easier. There's a lot of really good tutorials, so things like Lambda Island and purely functional TV. So you can actually do, I think if you know Clojure, you can do something within a couple of days, within a couple of weeks, you'll be very comfortable with. So I showed you a framework called OM, which I showed you that because it follows kind of the React kind of style and models the React APIs. There's other ones called Reagent, which are simpler. They do the Java server extensions kind of model. So all you're doing is really just creating HTML and some functions to manipulate a little bit of the events that are happening as well. So Reagent is probably kind of even easier to kind of learn. So yeah, I think if you understand the basics of Clojure, you can spend like a week solid, and you can be very comfortable like building sites on there because there's a lot of information out there as well. A question at the back there. Has Clojure or Clojuscript gained any traction at Salesforce? Yes, Clojure is used, but I only know of Clojure being used in the kind of DevOps world. So we use like things like Nginx, Clojure, and Puppet Labs to drive our stuff as well. So there's a lot of Java in Salesforce, so I've been trying to encourage them to use a bit more. There's a whole bunch of companies, including Uswitch and Funding Circle, and a whole other bunch of companies in London and San Francisco seem to be really big hubs of use of Clojure. Yeah, there's a lot of Clojure jobs out there as well. So it's quite a lucrative kind of role to get into, and it's definitely being used in production all over the place. So I mentioned Circle CI. We're using that extensively to build all their online tooling as well. Cognitech, a really good kind of resource if you wanted to get help with building Clojure stuff as well. Any other questions? Yeah, yes.
Are there any limitations of using this in Visualforce?
So you can include in Visualforce. So Visualforce is a basically web container inside Salesforce. So I've seen people putting things like AngularJS in there, and I think it's just a matter of kind of making sure you've got all the libraries you need inside there. It's a pretty flexible web container, so you can run Clojure scripts on GitHub pages, anything that really supports JavaScript. So I haven't come across any specific things. Obviously, you need a library to be able to talk to Salesforce as well, but there's quite a few of those out there as well.
Thanks.
Okay. Any other questions? No. No. Thank you very much for coming. Again, you can find the everything on. If you tweet me at jrocket, or it's on practically.github.io, you can find all the code there as well. Thanks again for coming. Thank you.